In this video, we're going to cover the basic precautions you need to take when testing old power supplies like these, and common failures you normally expect when you power one of them up. Alright, the basics. What do you need? Multimeter, check for output. A test power lead, a normal plug with alligator clips on the end. A automatic current limiting device, otherwise known as an incandescent light bulb, to go in series with the input so that if your power supply starts trying to short out or fail, it limits the current and stops blowing fuses. Plenty of alligator clip test leads, and an appropriate supply of resistive devices to properly load the supply to test for function. Preferably a range of resistance values. It can be incandescent light bulbs. And finally, last but not least, is a isolated main supply to plug your test power cord into, so that the item under test, which is this power supply, is fully isolated from AC power and is touch safe in case you have to make contact with the mains rectified side of the supply. Alright, now for basic failures I see in supplies that's been sitting around a while. Alright, now a basic overview of what you normally expect to fail on supplies when they're powered up the first time after a long period of inactivity. Supplies in question here, example supplies you see in front of you, were made in 1980, 1981, and 82 respectively. But with them and pretty much all other supplies, even newer ones, some of the common things that fail remain the same. One of the most common ones in powering up for the first time is the little film capacitors that usually reside in the AC line input filter network that resides right before the primary rectifier. Its job as a filter network is to stop the RF noise from the power supply bleeding back into the AC input line, and they often use film capacitors right here that have a tendency after they get old to get leaky and to make a nice dramatic display when they go out. In my testing, I've already had 3 of them go out just today, falling around with power supplies. So that's one of the reasons you use your automatic current limiting device. In case one of these goes, it just makes this bulb glow nice and bright with associated smoke, and you know you have to remove one of these devices. You can normally just take it out of the circuit and continue testing the supply, because all they are there for is RF filtering. The supply will continue to operate perfectly fine without them in the respective place. The other thing you have to watch out for is cook-off of one of the filter capacitors, either a main filter cap on the secondary filter caps. And if one of these goes, it goes, and it will take off, literally shoot up like a rocket. That's the reason why when you're testing a supply, you don't stick your head over top the power supply and look directly at it when you have it powered, because if one of those cooks off, it'll come straight to you, and you will not like the experience. So keep the artillery bank pointed straight up on the safe direction when powered. That way, if you have an unexpected artillery event, you will be scared the crap out of you, but you'll still be safe. Basic layout for testing a supply. Test power lead coming in, hooked in series with light bulb to the mains input of the supply. Other side of power lead coming directly to the supply. On the main output, main metered output of the supply, your voltmeter, and going to an appropriate load to load the supply, and hook your power cord to a fully isolated main source, and voila, 4.99 volts, which is the supply design voltage of 5 volts. And of course, I've already taken all the fun out of this video because I already had it tested earlier, and the pre-stated film capacitor let go, so all the smoke and fun is already said and done with on this supply. But for a 1980 supply, still cranking pretty good. And when it's operating, you can take and hook, the wrong lead, hook your meter to the other said outputs, check for output, and the other secondary outputs, 5 volts, 26 volts, which is kind of normal for a cross-regulated secondary output that's non-loaded. It specifies 24 volts, so it's within what you expect. Also the 24 volt output, which is running at 26, in 12 minus 12.19 volts, so the minus 12 volt output, which is going to running the regulators on here. So it's going to be pretty much a stable output no matter what the load is on it. Alright, that's basic precautions should take when testing a supply, and what to expect. And with this setup, if anything shorts, I don't have to worry about any fuses blown, because all it's going to do is cause that light bulb to light up and the supply will lose power. So, alright, next few videos I will take and go over in different supplies that I've got or salvaged, and what the general design constraints is, and what they're useful for. See you there.